Here we have the integral of x squared over the square root of x squared plus 9 dx. And seeing this denominator of this form has me thinking trig substitution. So I'm going to draw a triangle and I'm going to label the sides such that one of the sides will be the square root of x squared plus 9. So I'm going to call this one x, this one 3, and then indeed by the Pythagorean theorem we can see that this other side is x squared plus 9. So relating my two easier sides with the trig function with this angle theta here, tangent theta is going to be x over 3. So x is going to be 3 tangent theta, and dx would be 3 secant squared theta d theta. So we've got our substitutions ready. We need x squared, so that's going to be 9 tangent squared theta. And then we've got square root of x squared, that was 9 tangent squared theta, plus 9. And then our dx is going to be 3 secant squared theta d theta. Now let's see what we can do to simplify that. Down here in the denominator, if we factored out a 9, it'd leave me a tangent squared theta plus 1, which we know by the Pythagorean identity that that is secant squared theta, and we could square root both of those. The denominator would become 3 secant theta. Now we can cancel this 3 secant theta with this secant and with one of these. And so what I have left is this integral of 9 tangent squared theta secant theta d theta, because we took care of that denominator. Now what am I going to do with that? Well, the first thing I'm going to do is I'm going to use a Pythagorean identity on this tangent squared, and I'm going to move the 9 out in front as well. So that's going to be secant squared theta minus 1 multiplied by our secant theta d theta. I could express this as 9 times the integral of secant cubed theta d theta minus the integral of secant theta d theta. Now what do I do with that? Well, we've addressed that in an earlier section. So I have this secant to this nth power, and I'm going to use this reduction formula on that then. And this other one is a secant, and I've got this formula, and we saw how we could derive it, but we'll go ahead and just use them here since we've already done that. So this is going to be 9 multiplied by, and we're going to have secant theta, applying this formula, tangent theta over 2 plus, so our n is 3, so that's going to be 1/2 integral. If we had 3 minus 2, that would leave us a secant theta d theta. And then we still had this minus integral of secant theta d theta. So this formula helped us to get this down to something that involved a secant theta. We could actually combine then these two terms and leave us a minus 1/2 secant theta d theta. So I'm going to cross this one off and make this one a negative so that we could fit this on here. So now I can go ahead and apply this formula to work this second piece, and if I wanted I could distribute the 9 through as well. Move that box out of the way so we had room to do that. So that's going to be 9/2 secant theta tangent theta minus 9/2, and then using this formula we'd have the natural log of secant theta plus tangent theta, that quantity absolute value, and plus our constant of integration. But now our last step would be to get our solution back in terms of x. So it looks like we have 9/2 going back to our triangle, and looking here we have secant theta. Secant's a reciprocal cosine, so that's going to be hypotenuse over adjacent. So that's going to be the square root of x squared plus 9 over 3 multiplied by tangent theta, and we know tangent theta was x over 3, minus 9/2 times the natural log of square root of x squared plus 9 over 3 plus x over 3, replacing our secant theta and our tangent theta, plus a constant. So I'm out of room here, but our final answer, we could combine the 9 and the x here in the numerator, and in the denominator we could write that as 18. But there's our answer.